Welcome to Applied Animal Nutrition. Today we're going to talk about how to balance a ration using simple algebra and setting us up to be able to handle multiple ingredients down the road as well as multiple nutrient values. And so as we're working through this, we want to keep in mind a couple assumptions. One is, I know that everybody panics when they hear the word algebra. Lots of X's and Y's and Z's and unknowns and all of this stuff. But we're going to break it down pretty simply. And we're going to start off dealing with two unknowns. And for our example, we're going to have unknown A, which is feed A, and unknown feed B. Those are our two unknowns. So if we were to to pictorially represent this, we're going to have a new feed mix, a new ration, that is going to be 100% of this new feed. And we know that in here, some amount is going to be feed A, and some amount is feed B. We just don't know yet what those amounts are, and that's what we're going to work into solve. And so as we're going through that, we need to understand how algebra can apply in this setting to be able to help us solve for rations. So if we have two unknowns, mathematically we're going to express feed A as X and feed B as Y. And why? Because we have to. Just kidding. There's lots of algebra jokes out there. So our amounts are going to be X and Y for these two different feeds. So what we do know is that 100% of this feed is going to be equal to some amount of feed A plus some amount of feed B. And so mathematically we can start establishing an equation to solve for this. But because we have the two unknowns, it's a little squirrely looking right here. Sorry, that's a technical term. It's a little strange looking right here. But if we subtract X from both sides, we can actually solve such that Y is going to be the same expression as 100 minus X. So feed B can actually be represented as 100 minus X as well. So now, instead of two unknowns, we truly only have one unknown. So an equation is going to equal our new feed, or whatever the ration is, our goal. If we're solving for a certain amount of protein, that would go here. And we're going to literally be adding some amount of feed A plus some amount of feed B. But we're mathematically representing this as these two unknown values. And it's really simple with two ingredients because we have X and everything else minus X. So once we solve for X, we will automatically be able to calculate the amount of the second feed. So now we're down to one variable and we can solve these. And of course we'll work through an example. The first thing though is when you have a problem, you need to know how do you decide on X. What do? And X is always going to be equal to the feed with the highest concentration of the nutrient you are looking for. So if you're solving for protein, X is going to be the feed with the highest amount of protein. If you're solving for net energy, X is going to be the feed with the highest amount of net energy. Depends on, if you're solving for calcium, it'd be the feed with the highest amount of calcium. So I strongly believe in examples. So let's take a look at a problem. And so we're going to be balancing a ration for, our goal is 60% TDN. And so this could be a growing ruminant ration, like a growing steer ration or a lamb ration, that we want a certain amount of energy in our feed. And we're going to use steam-rolled barley and cottonseed hulls. So those are the two feeds. So I'm using a roughage, the cottonseed hull, and an energy feed, the barley, to balance this ration out. And so the first thing that we need to do is understand, and we're just going to solve this, all of these are on a dry matter basis. And so for this example, we're just solving everything on a dry matter basis. We're not going to be converting to as-fed or anything. But what we do need to know is the feed composition. So if I go to the Noble Feed Library and I look up steam-rolled barley, I'm going to find out that this is actually 84% TDN on a dry matter basis. If I look up cottonseed hulls, they are 45% TDN on a dry matter basis. So now I can set my X and my 100 minus X. So X, according to our rule that it's the feed with the highest nutrient concentration, in this example, barley is X because it has 84% TDN. Cottonseed hulls would be 100 minus X because it's lower in TDN with 45% TDN. And then our goal that we're solving for is 60% TDN. Now we have enough information to set up an equation. Now, what we're really going to be doing is we're going to be determining the specific amount of TDN now, for this example, coming from feed A and from feed B. So we're not just balancing for the amount of the feeds, but we're going to be using the calculation of getting to the actual amount of TDN. So if you remember from a previous video, to get to an amount of a nutrient, we multiply the weight or the amount of the feed times the percentage or concentration of that nutrient. So it's amount times the nutrient concentration. That is going to form the basis of how we set up our equation. So for this example, the first thing we do is I always put, and you can set it up where it's on either side, it doesn't really matter, but I like to keep things consistent, and so for 20 years, I have been putting the goal, okay, so this is our goal or our requirement, on the left-hand side of the equation. And now we're going to figure out how much barley is going to be in our ration. And so using that premise of the amount, in this case, we don't know the amount yet, but that's X. But we do know the nutrient concentration is 84% or 0.84. So this is the same as saying the amount times the nutrient concentration. We're going to add that to the amount of cottonseed hulls. And that's going to be the same principle. We know the amount is 100 minus X. We just don't know what X is. We got to solve for it. And so that's going to be 0.45. That's it. That's the equation we're going to be solving for to get to how much of the barley and how much of the cottonseed hulls we need to have in our ration. So let's walk through this just as a refresher here on solving algebra. So we are going to distribute the decimal across the different parameters. And so when I say that, we're going to multiply 0.45 times 100 and get 45 minus, we always got to keep the symbol, 0.45 times X. So now we can start combining like terms. The first step is to distribute across the variables. The second is to combine like terms. So in this case, I sometimes do this to help me in the beginning is take a look. Okay, 45 is a whole number. 60 is a whole number. I'm going to want to combine those terms. Oh, this is an x term. This is an x term. So I'm going to want to combine those terms. So we're going to start off by subtracting 45 from each side. That's how I'm getting rid of it on the right-hand side of the equation. But I also, whatever you do on one side of the equation has to happen on the other. So I'm subtracting 45 from 60. That leaves 15 equal to 0.84x minus, we gotta pay attention to that symbol, 0.45x, okay? So this is a negative sign, so it stays a negative sign right here. But we're still combining those feeds. It'd be the same as saying plus negative 0.45x. So now this is a like term and this is a like term. So we can subtract these and get 15 is equal to 0.39x. And so now we need to isolate x. So to do that, we're going to divide this value by 0.39. That's going to allow them to cancel out. But remember, whatever we do on one side of the equation, we have to do on the other. So we're going to divide the 15 by 0.39 as well. So we wind up isolating x, and x is going to be equal to 38.46. Great. We have a number. But I always get asked, well, great, I've got a number. What does this number mean? So what we're saying here is that x, let me go ahead and go back to green because that's what our original x was. X equals 38.46% barley in the ration. That's what we just solved for, was this unknown right here. So now we know the amount of barley in the ration. We can plug it in and now solve for 100 minus x, which is going to equal 61.54% cottonseed hulls. And these are both on a dry matter basis, because that's what we were solving for. But it really wasn't that hard to do to be able to establish how much of each feed we need in the mix. Now, the last important step that we always should do, and I have to admit I get lazy too, and it would save me a ton of trouble if I actually did it, is to do a check. I'm going to do that in blue, the check. And so now what we want to do is just plug it in. So we know 60 should equal 0.84 times x, so we're going to pull that in, the 38.46 plus 0.45 times 61.54, because that's representing 100 minus x. So if we go ahead and go through this process, what you'll find is that if you run this through the calculator, it indeed does equal 60, and so our math checks. And you've just balanced a ration using algebra. So for all you high school students and whatnot that are wondering why algebra is important, here's why. For me, it actually makes sense when it's applied to feeding livestock. It's like, oh, totally makes sense when you're dealing with ingredients and pounds of feed as opposed to just X's and Y's. So I hope that helps you understand a little bit about how to use simple algebra to solve for two unknown ingredients. We'll also be discussing how to use algebra when you have a fixed ingredient, like a certain amount of a supplement fed at a specific amount. It's the same principle, just one more step that we add in. So hopefully this helps and you enjoyed the applied animal nutrition. Have a great rest of your day.